Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, consider the function f of x equals 3x exponent 4 plus ax cubed plus bx squared plus cx plus d. And in part A, we have to find constants A, B, C, and D such that the graph of f will have horizontal tangents at -2, -73, and 0, -9. Now, as per the problem, the graph has horizontal tangents at these 2 points. That means these 2 points lie on this function. Now, the second point, 0, -9, represents the y-intercept for this function f of x because its x-coordinate is equal to 0. So we should start by subbing in this point 0, -9 in the given function equation. So we get, so for part A, so we'll sub in the function value as -9 and x as 0. So we get 3 times 0 exponent 4 plus a times 0 cube plus b times 0 square plus c times 0 plus d. So as a result, so the first 4 terms become equal to 0. So as a result, we are just left with -9 equals d. So this is the final answer for the value of d. Now we can sub in our second given point at which the tangent is horizontal to the function. So the point -2, -73 also lies on this function. So we can sub in the function value as -73 and sub in x as -2. So 3 times -2 exponent 4 plus a times -2 cube plus b times -2 square plus c times -2, and the d value we found to be -9. Now we can simplify this equation. So -73 equals, so first we can do 3 times and then -2 exponent 4, which is equal to 48. Now we have to do a times -2 exponent 3. So -2 exponent 3 is -8. So we get -8a. And then -2 squared is 4. So we get plus 4b. And then -2c. And then minus 9. Now we can combine 48 and -9 on the right side. So we get -73 equals, so 48 minus 9 is equal to 39 minus 8a plus 4b minus 2c. Now we can combine -73 and 39 by subtracting 39 from both sides. So 39 on the right side will get cancelled out. So we are left with -112 equals -8a plus 4b minus 2c. So this is our first equation with a, b, and c. Now we are also given that the tangent is horizontal to these two given points. So if a tangent is horizontal, that means its slope is equal to 0, and we know that the slope of a tangent is equivalent to the derivative of the function. So that means the derivative of the function at these 2 points should be equal to 0. So we can start with the y-intercept point. So the first step is to find the derivative of the given function. So prime of f at x equals, so for the first term 3x exponent 4, so we know 3 is the coefficient, so it will stay as it is, and as per the power rule, the derivative of x to the exponent 4 will be 4, and then x exponent 4 minus 1. So as per the power rule, we move the exponent to the front and then we subtract 1 from the exponent, and then plus. So in the second term, the exponent a will stay as it is, the coefficient a will stay as it is, and then for x cube, we'll use the power rule. So we'll move the 3 to the front and we'll subtract 1 from 3, and then plus. Now b is the coefficient, so it will stay as it is, and as per the power rule, we'll move the 2 to the front and subtract 1 from 2, and then plus. So for cx, so c is the coefficient, so it will stay as it is, and the derivative of x is 1. Now we know d value is -9, and 9 is a constant, so its derivative is equal to 0. Now we can simplify this equation. So prime of f at x equals, so 3 times 4 is 12, and then x cubed, and then plus 3ax squared plus 2bx plus c. Now as per the problem, the tangent is horizontal at 0, -9. So that means we'll sub in the prime of f at x as 0 because the slope is 0, and x as 0 because in the point 0, -9, the x coordinate is 0. So we get 12 times 0 cubed plus 3a times 0 squared plus 2b times 0 plus c. So the first 3 terms in this equation go away because multiplication by 0 makes these 3 terms equal to 0. So we are left with just 0 equals c. So this should be the final answer for the value of c. Now we can sub in the other point -2, -73 in this derivative equation because the tangent is horizontal at that point as well. So we can start on this side. So now the left side will be 0 equals, and we'll sub in x as -2. So we'll use the derivative equation. So 12 times -2 cubed plus 3a times -2 squared plus 2b times -2, and the c term goes away because c is equal to 0. Now we have to simplify this equation. So we get 0 equals, so -2 exponent 3 is -8. So 12 times -8 is equal to -96. Now -2 square is equal to 4, and 4 times 3 is 12. So we get 12a. And then 2 times -2 is -4. So we get -4b. Now we can move the 96 to the left side. So we add 96 to both sides. So the 96 on the right side get cancelled out. So we get 96 equals 12a minus 4b. So this is the second equation we get with a and b. Now we can use the first equation we got for a, b and c and sub in c as 0 in that equation. So this equation changes to negative 112 equals negative a plus 4b. So the c term in this equation goes away. So we get a linear system with variables a and b. Now we have to solve this linear system to find the value of a and b. So for this linear system, we can use the elimination method, because if we add these two equations, the b terms will get cancelled out because they have the same coefficient with opposite signs. So if we add these equations, so 96 plus minus 112 is equal to negative 16 equals, then 12 plus negative 8a is equal to 4a, and negative 4b plus 4b is 0 because they cancel each other out. Now we can isolate a, so we should divide both sides by 4. So the 4's on the right side will get cancelled out, and negative 16 over 4 is equal to negative 4. So that means the final answer for value of a is negative 4. Now we can find the value of b, and for that we can sub in the value of a into one of these two equations. So we can use the first equation. So as per the first equation, 96 equals 12 times, so we sub in a as negative 4 and minus 4b. Now we can evaluate 12 times negative 4. So 12 times negative 4 is negative 48. So 96 equals negative 48 minus 4b. Now we can add 48 to both sides because we have to isolate b. So the 48 on the right side will get cancelled out. So we can do 96 plus 48, which is equal to 144. 144 equals negative 4b. Now we can isolate b by dividing both sides by negative 4. So the negative 4 on the right side will get cancelled out. So 144 divided by negative 4 is equal to negative 36. So this should be the final answer for the value of b. So we are done with part A. Now we can analyze part B. Now as per part B, there is a third point that has a horizontal tangent. Find this point. So that means at this third point, so the tangent is horizontal and we have to find this third point, and a horizontal tangent has a slope equal to 0. That means at this third point the derivative of this function should be equal to 0. So we should start by writing the derivative of the function that we found in part A. So that's this equation, and we can sub in the appropriate values of a, b and c. So we got prime of f at x equals, so 12x cubed plus 3a. Now we got the a value as negative 4, so 3 times negative 4, and then x squared, and then plus 2. Now the b value we got is negative 36x. Now the c is equal to 0, so we can ignore the value of c. So we can simplify this equation as prime of f at x equals 12x cubed minus 12x squared, then minus 2 times negative 36, which is equal to negative 72x. Now we are finding the point at which the tangent is horizontal, so we can sub in prime of f at x as 0, and we get 12x cubed minus 12x squared minus 72x. So now we have to solve this equation. So we can start by doing common factoring on the right side of this equation. So we can factor out 12x. And in the parentheses, we get x squared minus x minus 6. Now there is a simple trinomial in the parentheses, so we can factor it. So we can use the sum and the product rule. So the sum should be negative 1 and the product should be negative 6. So the two numbers that we are looking for are negative 3 and 2. So the factored form will be x minus 3 and then x plus 2. So now we get three cases. So the first case is 12x equals 0 and we divide both sides by 12. So the 12s on the left side get cancelled out. So we get x equals 0. Now the middle case, so x minus 3 equals 0. We add 3 to both sides. So the 3's on the left side get cancelled out. And we get x equals 3. And now for the third case, so we do x plus 2 equals 0. And now we subtract 2 from both sides. So the 2's on the left side get cancelled out. So we get x equals negative 2. See, we got three x values at which the tangent is horizontal. Now in part A, we are already given 2 points at which the tangent is horizontal. So negative 2, negative 73, which corresponds to this x value, x equals negative 2, and then 0, negative 9, which corresponds to x value, x equals 0. So that means the third point that has a horizontal tangent has x value equal to 3. So this is the x value we are looking for part B. Now we can find the function value at x equals 3. So for that we can sub in x as 3 in the given function. So in the given function we can sub in x as 3. So f at 3 equals 3 times 3 exponent 4 plus a. Now we got the a value as negative 4. So negative 4 times 3 exponent 3 and then plus, and we got the b value as negative 36 times 3 squared and then plus, so we got c equals 0 times 3 and d is negative 9. So now we have to evaluate this expression. So 3 times 3 exponent 4, so it's 243 and then minus 4 times cube of 3, which is equal to negative 108 and then negative 36 times 3 squared, which is negative 324. So 0 times 3 is 0, so it goes away, and then negative 9. Now we can combine all of these numbers. So 243 minus 108 minus 324 minus 9 is equal to negative 198. So that means the third point is 3 comma negative 198. So this should be the final answer for part B. Now we can analyze part C. So we can move on to the next page. Now in part C, we have to find for all 3 points, determine whether each corresponds to a local maximum, a local minimum, or neither. So for part C, we'll have to use the first derivative test. So the first step is to find whether the function is increasing or decreasing on the left and the right side of these points where the tangent is horizontal. So first, for that we'll have to use the number line method. So we'll start by drawing the number line. And on this number line, we'll plot the critical numbers, which are the x coordinates of the points where the tangent is horizontal, or prime of f at x is equal to 0. So the points are negative 2 and then 0 and then 3. So the 3x values we got in part B. Now we have to find whether the sign of prime of f at x is positive or negative on the left and right hand side of these critical numbers. So for that we'll use the test values in each part of the number line or the interval. So to the left side of negative 2, we can use the test value negative 3. Between negative 2 and 0, we can use the test value negative 1. Between 0 and 3, we can use the test value 1. And to the right side of 3, we can use the test value 4. Now we'll have to use the prime of f at x function. So prime of f at x we got as prime of f at x. So I'll just rewrite the equation for prime of f at x equals, so there was 12x cubed and then it was negative 12x squared and then minus 72x, because and there was no c term because c is equal to 0. Now we'll start by subbing in the first test value. So we'll sub in x as negative 3. So prime of f at negative 3 equals 12 times negative 3 cubed minus 12 times negative 3 squared minus 72 times negative 3. So now we can evaluate this expression. So 12 times negative 3 cubed is equal to negative 324. And then negative 12 times negative 3 squared is negative 108. And then negative 72 times negative 3, which is 216. So in this case, we get a negative value. So we are not interested in the number, but only the sign of the number or the value we get. So in this case, so prime is negative on the left side of the critical number, x equals negative 2. That means the function is decreasing on the left side of negative 2. So as you may know, when the prime of f is greater than 0, that means the function is increasing. And when the prime of f is less than 0, That means the function is decreasing. Now we can do the analysis for the second test value, -1. So prime of f at -1 equals 12 times -1 cube, then minus 12 times -1 squared minus 72 times -1. So prime of f at -1 equals, so 12 times -1 cube will be equal to -12, and -12 times -1 square will be -12, and 72 times -1 will be positive 72. That means the overall result will be a positive value. That means the function is increasing between critical numbers -2 and 0. So now we can use the third test value 1. So prime of f at 1 equals 12 times 1 cube minus 12 times 1 squared minus 72 times 1. So now we can evaluate this expression. So prime of f at 1. So 12 times 1 cube is 12, and then 12 times 1 square will be 12, so minus 12, and then minus 72. So in this case we'll end up with a negative value for prime of f. So that means the function is decreasing between critical numbers 0 and 3. And now we can use the fourth test value. So prime of f at 4 equals 12 times 4 cube minus 12 times 4 squared minus 72 times 4. So prime of f at 4. So we start with 12 times 4 cube, which is equal to 768. And then 12 times 4 squared, which is equal to 192. And then 72 times 4, which is 288. So the result here will be positive. That means the function is increasing to the right side of the critical number x equals 3. So now we can use these results to conclude whether each point corresponds to a local maximum, minimum, or neither. So let's start with the first critical number, x equals -2. So on the left side of -2, the function is decreasing, and on its right side, the function is increasing. That means there is a local minimum at the critical point -2, -73. Now we can analyze the second critical number. So x equals 0. Now to the left side of x equals 0, the function is increasing, and to the right side, the function is decreasing. So that means there is a local maximum at 0, -9, the critical point for which the critical number is x equals 0. Now we can analyze the third critical number, x equals 3. Now to the left side of 3, the function is decreasing, and to its right side, the function is increasing. So that means there is a local minimum at the third point that we found in part B, which is 3 and then -198. So this should be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.